Hello, grade 8. In this video, you will get the solutions to the exercises from the workbook concerning Newton's third law. So workbook page 20, 21, 22, and 23. The first one. Predict the corresponding result for each force. The answers are on page 70 in your book. An airplane's jet engine pushes air towards the back of the plane. So what's going to happen is the air pushes back and the airplane moves forward. The second one. A fisherman tosses an anchor away from his boat. The anchor applies a force on the fisherman and his boat, pushing him in the opposite direction. The third one. A skier digs ski poles into the snowy ground and pushes down and backward. The ground pushes back and moves the skier forward. So these are the forces and the results, the actions and the reactions. The second exercise. Summarize Newton's third law of motion in your own words. You can use your own words as long as you use scientific terms. The answer is on page 71. When one object applies a force on a second object, the second object applies a force of the same size but in the opposite direction on the first object. This is Newton's third law of motion. Define force pair and identify the two parts of a force pair. The answers are on page 71. A force pair. The forces two objects apply on each other. So I have two forces and two objects. The first object applies a force on the second one, and the second one applies a force on the first one. This is why I have what I call a force pair. I have the action force from one side and the reaction force from the other side. Compare forces in a force pair. The answer to this question is on page 71. So, the action force and the reaction force. If I'm talking about the size, they have equal size. If I'm talking about the direction, they will have opposite direction. So they are equal in size but opposite in direction. Now, analyze why force pairs do not cancel each other. Since they are equal in size and opposite in direction, some of you might think, why don't we get balanced forces? So the answers are on page 71. Equal and opposite forces, they are applied by two objects, one on another. This is why they don't cancel each other. We said we have two forces, they are equal but opposite in direction, but they are not applied on the same object. This is why I have a force pair. Whereas when I have equal and opposite forces applied on the same object, I will get balanced forces, or net force equals to 0. Summarize the comparison above. The answer is on page 71. You can use your own words as long as they're scientific. Combining forces results in a net force of 0 only if the forces act on the same object. In the case of the Newton's third law, I have two objects. This is why I cannot add the two forces. Classify forces in the sentences below. Underline action forces, circle reaction forces. The answers are on page 71. A swimmer pushes his arm back against the water in a pool, and the water pushes forward against his arms. So the action is pushes his arms back, and the reaction is the water pushes forward. The second one. A rocket engine pushes hot gas out in a downward direction, and the hot gas pushes upward on the engine. The action is pushes hot gas out in a downward direction, and the reaction is hot gas push upward. And the last one, a trampoline hurls a girl into the air. I have here one force, and it is a reaction. Now, define momentum. This is on page 73. It's the measure of how hard it is to stop a moving object. Explain the equation for momentum. Momentum equals m times v. The answer is on page 73. The first letter, which is rho in Greek, it looks like a P, but in fact it's not a P. It is for the momentum, and the unit of the momentum is kilogram meter per second. M is for the mass, and it is in kilogram, and V is for the velocity in meters per second. Analyze momentum. Determine the momentum for each object. Circle the object that would be more difficult to stop. So I have two objects here. A 10 kilogram shopping cart moving at 5 meters per second, and a 2 kilogram ball moving at 28 meters per second. The first thought might be the shopping cart has a bigger mass, so it would be harder to stop it, but the answer is on page 73, and it will be harder to stop the 2 kilogram ball because it's moving at 28 meters per second. Now, if we calculate the momentum for each case, in the first case, m times v, 10 times 5 equals to 50 kilograms meters per second. Whereas the second one, 2 times 28, you'll get 56 kilograms meters per second, which is bigger than 50. So it will be harder to stop the ball and not the shopping cart. Summarize the law of conservation of momentum. The answer is page 74. So, the total momentum of a group of objects stays the same unless outside forces act on the objects. Contrast type of collisions. The answers are on page 74. So I have elastic and inelastic collisions. Both objects collide, momentum conserved. So in both cases, I will have the same momentum, the same net momentum, if you want to say, before and after. But in the elastic, they bounce off each other, whereas in the inelastic, they stick together. If you have ever been in a car at a stoplight beside a large truck, you probably noticed that the car took off from the stop much more quickly than the truck. Explain why it is harder to start and stop the motion of a large truck than that of a small car. You can use your own words. One simple answer would be the truck has a greater mass than the car, so it requires more force to set it in motion. When the truck is moving, its greater mass causes it to have greater momentum, making it harder to stop the motion. Thank you very much.